Well, welcome to part two. Now we're going to look at a hemisphere, which is half a sphere. And in this case, they're telling us that the volume is 1526.8. So we're stretching this question now a bit further than maybe I suggested last time, because I think why not? Here, they give you the volume, and you've got to work out what the radius is of the hemisphere. Now there are two ways to do this, but I think the easiest way is to go this way. If we know that the hemisphere is that, and that's half the volume, I can double that to get the full volume. So if I'm going to write here full volume, it's going to be twice that, isn't it? Because that then tells me what the full volume of the sphere would be. So I get my calculator, 1526.8, and double that, and I get the answer 3053.6. Now, it's good practice not to round up until the end. Now, that is the volume of the full sphere. Okay. Now, you could have done it a different way, but I think this is nicer because I'm dealing with less fractions. And fractions create friction, and we don't want friction, do we? No, we don't. So, here goes. If I know the volume is that, and I know the formula says this, then this equals that. Meaning, I get 3053.6 equals 4 over 3 pi r cubed. Now that could look really confusing, okay? And I get that. I get it can look really awkward. Remember, that's just a number, okay? It's not what we call a variable. It doesn't change. It's just a number. So I'm going to answer it this way. 2 lines either side. And then I'm going to get rid of things on this side. But whatever I do to that side, I must do to the other as well. So first thing I'm going to do is get rid of the divide by 3. So I'm going to times both sides by 3. Okay, so I have kept that number in there, and I times by 3, and I equal it. So on my left hand side, if I times that by 3, I get 9160.8. And on this side, because I've times by 3, I cancel that function. So I'm left with 4 pi r cubed, because I've got rid of the divide by 3. Now what I want to do is deal with the times by 4. How do I get rid of times by 4? Well, I divide both sides by 4. Keeping that still where it is, I haven't got rid of that, so I'm going to divide by 4 equals 2290.2. 2290.2. Now, that doesn't equal 4 pi because I've got rid of the 4, it equals just pi r cubed. Okay, let's deal with the pi. Well, that's also times, so I'm going to divide by pi. So keep that there, divide by shift. It's a bit awkward, but you get used to it in the end. And I get 278.99. So 728.99. My dyslexia showing. Equals r cubed. Now finally, I want to get rid of the r cubed. And I think, how do I get rid of r cubed? Well, the answer is cube root it. The cube root. So I'm going to cube root both sides. And that should give me the value of r. So r is going to equal, so I get that. Now how I do this is interesting, okay? There's different ways of doing it, but you can just about see here, there's a little 3 in front of the tick box. So if I do shift that number and then put in the answer and equals, then I get 8.999997. That is 9. Okay? And that's how you work this out. It looks quite complicated. Let's just quickly go through. Firstly, they gave you the half a sphere, the hemisphere, and they told you the volume equaled this. And they wanted to find the radius. So to do that, I doubled this to get the big sphere. and that's the volume of the big sphere, the full sphere. Now I know that this equals that, because this is the volume. So the volume equals this, and the volume equals that, then this equals that, and I form myself an equation. I then have to deconstruct all of the things attaching themselves to R here. I got rid of the divide by 3 by timesing both sides by 3. I got rid of the times by 4 by dividing both sides by 4. I got rid of the times by pi by dividing both sides by 5. And I got rid of the to the power of 3 by cube rooting. I followed BIDMAS, okay, in order to work out what to do, but went the other way, okay, sad mob, in order to deconstruct. So I just got R equaling 9. Hope that's helped.